Good morning, everybody. We're going to do things a little bit differently in this unit because this unit's a lot of talking, so you're going to see a lot of my face instead of just blank screen. So today I can determine which statistical study was performed by understanding the components for each. So we're going to talk about the different types of statistical studies. There are three. We're going to talk about what they are. We're going to talk about the difference between them. That's going to be the point of this lesson. So there are three types of statistical studies we're going to be talking about. The first one is a survey. And a survey is one that probably all of you at some point in your life has been involved in, whether you've formed one or been a part of one. And a survey is basically when you ask somebody something. So if you want to know the type of foods the students in your class like to eat, or if you want to know how much time someone spends on their homework, a survey is when you are asking people something. The components of a survey, you are asking people something. Now, we're going to talk more about the sample and who you're going to be asking in a later lesson, but basically what you need to know for this lesson here is that for a survey, you're asking somebody something. The next type of statistical study is an observational study. So we'll just talk about the last two. There's an observational study, and then there's a controlled experiment. An observational study is where the person conducting the study doesn't actually apply a treatment, doesn't actually give any of the subjects anything. The observational study is where you're basically just looking at data at something that's already happened and analyzing it. So for example, if I want to know if speeding leads to car crashes, I'm not going to make people get in the car and speed. I'm just going to look at the data from all the different car accidents and see the data of who is speeding and see if I can draw any conclusions from there. So in an observational study, the person doing the study is basically just observing and looking at the data. They're not actually doing anything. Whereas a controlled experiment, the researcher is physically going to apply a treatment. So if I want to know if a drug works, and we're going to talk in more detail about how a controlled experiment works. If I'm going to give one group the drug and the other group something else, that's a controlled experiment because the researcher is actually applying a treatment. I'm actually giving something to one of the groups. So a survey, you're asking somebody something. An observational study is where you are not physically involving yourself in whatever's going on. You're just analyzing the data. You're observing the data of something that's already happened. And a controlled experiment is where you are interjecting yourself. You are applying a treatment. You're giving something to a group and you're not giving something to another group or a placebo. But again, we're going to talk about each of these three statistical studies in separate lessons later on. Now, all of these types of statistical studies can produce correlations and relationships between data, but only one of them can create a causal relationship. The only type of statistical study that can create a causal relationship is a controlled experiment. So let's kind of jot down what you need to know that we just talked about. So a survey is where you are asking people something. An observational study, the observer does not apply a treatment, just observes and analyzes data without being involved. So again, if I want to know if speeding causes car crashes, that would be an observational study. The person analyzing the data is not actually putting people behind the wheel and making them speed. They're just looking at the data that already exists. Whereas a controlled experiment is the opposite of that. The researcher applies a treatment, gives a drug, tries out a type of seed on a plant, whatever is going on, that the researcher is actually doing something. And the only one that they can all they all can suggest relationships and correlations, but the only one that can create a causal or cause and effect relationship is a controlled experiment. So if I want to know if speeding causes car crashes, then I would need to do an experiment where I'm taking, and again, we're going to talk more about specifically how to do these experiments later on, but I'm going to take a group of people, I'm going to make them speed, I'm going to take another group of people, I'm going to have them not speed, and then I'm going to watch them crash their cars and analyze their data. So that would probably never happen because ethically we can't, say it's okay to cause people to get into car accidents. So we could probably never say that speeding causes a car accident, but I'm sure if you looked at the data and did an observational study, we would find that there's a relationship or a correlation between the speed that drivers drive and the amount of car accidents they get into. So let's take a look at some of the examples at this point. For which scenario? Which scenario is best describes an observational study? So an observational study is where we are not actually performing, we're not giving anybody anything, we're not asking anybody anything, we're just kind of looking at the data. So we're gonna go through each choice, we're gonna talk about which type of statistical study it is. For a class project, students in health class ask every 10th student entering the building if they eat breakfast in the morning. Well, since they are asking people things, that's a survey. A social researcher wants to learn whether or not there is a link between attendance and grades. She gathers data from 15 school districts. So she's not asking anybody anything. She's not forcing people to go to school and not go to school. She's just taking a look at data that already exists. This is an observational study. A researcher wants to learn whether or not there is a link between children's daily amount of physical activity and their overall energy level. During lunch at the local high school, she distributes short questionnaires to students in the cafeteria. She's asking students a question. That's a survey. 60 seniors taking a course in advanced algebra concepts are randomly divided into two classes. One class uses a graphing calculator all the time. The other class never uses graphing calculators. A guidance counselor wants to determine whether there is a link between graphing calculator use and the students' final exam grades. We're giving students calculators and we're not giving students calculators. We're applying a treatment. That's a controlled experiment because we're physically giving one of the groups something, in this case, calculators. The question was asking which is an observational study. Choice 2 is an observational study. Now, let's just talk about what a census is because we haven't talked about what a census is. So let's just talk a little bit about surveys. So if I want to find out, let's just bring my face back up here. If I want to find out, I don't know, how the school feels about chicken nuggets, because we all love food. I'm going to do a survey and I'm going to ask some students in the school what they feel about it. Now, the population is the entire school. All right, so the population of my survey is all the students in the school. From that population, I'm going to choose a sample. And we're going to talk about what a good sample is and what a bad sample is in a later lesson. But basically, a good sample, I want it to be random. So maybe every 10 student walking in the building in the morning, I'm going to ask. That's the sample that represents the population. But every 10th person that I ask walking in the building is the sample that represents the population, which is all the students in the school. So a census is basically a survey where I ask every member of the population. So if I wanted to perform a census, I would literally have to ask every single student in the entire high school, whether they're an A day or a B day, or they are remote, or they are homeschooled. So it's not very practical to do a census. It's very difficult to do a census, but that's what a census is. A census is a survey where every member of the population is involved in that survey. Now, you might hear census, like the government sends out a census I believe it's every 10 years. And by law, every single member of the population has to send that back. That's why it's called the census, because every single member of the population is included in it. So that's what a census is. So I didn't talk about that earlier, so let's talk about that now. You know what? Why don't I share my screen? That way you can see my face as we go through all that. So you can see all my facial expressions and whatnot. See? Hi. All right. So a doctor wants to test the effectiveness of a new drug on her patients. She separates her sample patients into two groups and administers the drug to only one of these groups. She then compares the results. What type of study did this doctor do? Well, she separated her patients. She administered the drug. She applied a treatment to one of the groups. She did a controlled experiment. She didn't ask anybody anything. She didn't observe. She did it. She administered the drug. She was involved there. It wasn't like the first example where this person just gathered data from the school districts. If I gathered data from the school districts, I didn't do anything to affect the data. I just pulled the data. But here, she's administering, she's administering the drug. She's applying a treatment. That's a controlled experiment. Let's take a look at 3. Which task is not a component of an observational study? So again, an observational study, I'm not physically applying a treatment. I'm not physically giving anything to anybody. So I want you to read through this, and I want you to try and do it on your own. So I'll just chill here for like 20 seconds while you read through it and decide what you think the answer is. Okay. Choice 1, the researcher decides who will make up the sample. Yeah. All right. The researcher is going to decide what he or she wants to look at. Choice 2, the researcher analyzes the data received from the sample. Yeah. The researcher is going to look obviously at the data to see if there's a pattern or a relationship. The researcher gathers data from the sample using surveys or taking measurements. Yeah, the researcher can gather the information that was provided. The researcher divides the sample into two groups with one acting as a control group. That is a controlled experiment. The controlled experiment is where I'm physically taking the people, dividing them up, applying a treatment. Choice 4 would be an example, would be a component of a controlled experiment. It's not the answer. Which statement about statistical analysis is false? So this is something that we talked about at the beginning. So I'm going to give you a little bit of a hint. This question is based on this concept right here. So read this for a moment. And then read this. And I'll give you about 20 seconds to come up with your answer. Which statement about statistical analysis is false? Experiments can suggest patterns and relationships in data. Yes, they all can. Experiments can determine cause and effect relationships. Yes, controlled experiments is the only one that can determine a cause and effect relationship. Observational studies can determine cause and effect relationships. No, the only one that can determine a cause and effect relationship is to perform a controlled experiment. Observational studies can suggest patterns and relationships. Yes, an observational study or a survey cannot determine cause and effect relationships. Only a controlled experiment can. So the rest of this is basically just more questions based on the same thing that we just talked about. So, you know what? Why don't you pause, try 5 and 6 on your own, and then I'll go over 5 and 6, and then I'll let you practice on your own after that. So please pause, try 5 and 6 on your own, and then unpause. Okay, now that you tried 5 and 6 on your own, a market research firm needs to collect data on viewer preferences for local news programming in Buffalo. Which method of data collection is most appropriate? Well, if you want to know what viewers prefer, you kind of have to ask them. Survey. A census would not be practical because how in the world are you going to ask every single person in Buffalo what type of, local news they want? Survey would definitely be the most appropriate there. A school cafeteria has 5 different lunch periods. The cafeteria staff wants to find out which items on the menu are most popular, so they give every student in the first lunch period a list of questions to answer in order to collect the data. It's a survey. And again, you're not going to ask, so a population survey means the same thing as a census. I'm not asking every single person, I'm asking a sample. That's every student in the first lunch period, not every student in the entire school. It would be a sample survey. You know what? Why don't we do one more? Why don't you try number 7 on your own, both A and B? So try 7 on your own. Sorry, so pause, try 7 on your own, unpause. All right, now that you tried number 7 on your own, is the following an observational study or an experiment? A study is done to see how high soda will erupt when mint candies are dropped into 2-liter bottles of soda. You want to compare using 1 mint candy, 5 mint candies, and 10 mint candies. You design a cylindrical mechanism which drops the desired number of mint candies at once. You have 15 bottles of soda. You randomly assign 5 bottles into which you drop 1 candy. 5, 10, you're dropping the candies. You are actually doing something that to affect the outcome. That's a controlled experiment. You want to see if 5th grade boys or 5th grade girls are faster at solving Ken puzzles. You randomly select 20 5th grade boys and 20 5th grade girls from 5th graders in your school district. You time and record how long it takes. You're not doing anything to affect how fast they're doing it. You're just observing how fast they're doing it. That's an observational study. If you were doing something to affect how fast they were doing it, that would make it into a controlled experiment. Here, you're physically dropping things in. You're physically altering the outcome. You're not doing that in B. You're just observing how fast they're doing it without affecting how fast they're doing it. So your classwork / homework is to finish this worksheet. Again, there are 3 types of statistical studies. Survey, you're asking somebody something. Observational study, you are not physically affecting one of the groups. You're just analyzing the data that already exists. Controlled experiment is where you are physically applying a treatment. You are physically giving one of the groups something. And while they all can suggest relationships and correlations between 2 things, the only one that can create a causal relationship is a controlled experiment. Again, your classwork / homework is to finish this, and in the following lessons, we are going to go into detail on each of those types of statistical studies. Have a great day.